Alright, I'm Jordan Albert.
I'm Ed Lee.
I'm Nick Johnson.
And I'm Marcus Gray, and we decided to redesign the microwave interface. The microwave is a device I'm sure everyone in this room is familiar with. Everyone probably has a microwave in a dorm room, apartment, or home. If not, they probably still use them very frequently. Our design is aimed towards a huge variety of people, and because of that, we wanted it to fall within the average price of a microwave. Every model of microwave has a different interface, and this lack of standardization makes using a new microwave a very difficult task. Microwave interfaces are cluttered by functions whose small amount of actual use makes them more of a hassle than a convenience. Microwaves rely greatly on conventions, which must be done with each interface instead of relying on user-friendly affordances which convey their function. Microwave interfaces also leave little room for error in their use. There is only one and only way to complete a task.
In designing our microwave interface, we found that many problems had overlapping solutions. The lack of interface standardization in the current market amongst the various manufacturers and even amongst the various model types could be solved in our interface by increasing learnability and adaptability. We replaced conventions with affordances. For example, we opted for a handle to open the door as opposed to a button, switch, or lever, which would pop the door open. We also made sure that the button functions, as well as the current operation mode, were clearly labeled on either the screen or through button backlighting. And this was to help make the information more clear to the user. Another way we increased learnability was by reducing the clutter in our interface, by moving seldom-used functions, such as shortcut keys, power settings, and clock functions to the submenus. We were able to keep the interface simple, ensuring that the user wouldn't become overwhelmed by clutter. We also made it a point to make the submenus just as easy to read and to use. And to deal with the problem of conventions, we eliminated as many as possible and replaced them with affordances. We designed the interface to conform with the user's expectations from using other microwaves. So standards such as hitting start or back to confirm choices were found in our interface. We also let the interface tell the users what various functions did, whether through the handle, which instinctively affords pulling to open a door, or through the use of LED backlighting, which clearly indicates the current microwave function. This also meant that making our interface work with expectations learned from many different interfaces. So we included multiple paths or options to complete a single task. An example of this is that our cook time function can be entered through just simply entering the duration of cook time and then pressing start. However, if the user has learned the convention of hitting cook time, the button cook time before entering the time, this won't have an adverse effect. A side benefit of this is that our interface is now more easily adaptable to errors. And what would otherwise be an error on the interface would be an alternative method for completing the task. And through these solutions, we came up with a prototype interface. Yeah, it's fully touchscreen. It has a backlighting for buttons to indicate the mode of operation or the currently active button. Right now, the interface also provides oral and visual feedback. And our team identified setting cook time, setting the kitchen timer, and setting the time of day as our most central and important tasks for a microwave. So in testing our interface, we measured its usability through these tasks. And I'll now switch to Jordan to elaborate.
When testing our interface, we utilized a paper interface, a mock paper interface, and used a Wizard of Oz method of progressing through the functions using various overlays as the participant moved through their assigned task. We videotaped our usability trials while our participants followed a verbal protocol, which allowed us to know their thought processes as they went through the tasks. And we then had multiple judges view the videotapes at separate times to collect the data from our trials. And this allowed us to make sure that we had a high inter-judge reliability in our data. Our usability testing got us some good data, and a lot of the important data is on this table here. And I'll just explain it real quick. Across the top here is the 3 tasks that we had each participant do. And then down in the rows we have the max time to complete the task, minimum time to complete the task, average time to complete the task, and then for each task we have the total errors across all participants down at the bottom. We think that this is pretty good data. We think the times are good, and we're especially happy with the low number of errors that we got. And we think when taking certain factors into effect, when we take certain factors into effect, that these times would be even better if completed on a real interface in a more realistic environment, because there'd be less confusion and less time taken by manually advancing through the mock prototype. And we also think that both time and errors would be reduced on the setting the time of day task, so right here, which had the most errors and took the most time. And we think that some of that came from the fact that in all 5 trials, for all 5 participants, we ran this task third, and it was the most complicated and different from the other tasks, which used the main interface, while this task used more of the submenus. And we think that that kind of created an expectancy effect when we came to this third trial, that people were searching for how to do the task on the main menu instead of going to the options menu at the top of the interface. And so through our testing, we found our participants made few errors, and we were happy to see different participants using different methods for single tasks. We did discover that we could do more to reduce clutter because people were still making mistakes when advancing through submenus. One positive and surprising thing that came out of a participant making an error was an instance where, after making an error, the participant, without being told to do so, used the cancel/stop button to correct the error and continue on with the task.
From our usability testing, we settled on several changes to the design of our microwave interface. We removed unneeded information from the main screen, making it possible to cancel time entry, and created even more ways to complete a single task because we felt that that was our interface's greatest strength. Additional features beyond our 3 main tasks, which we would implement in our design, are a mute function, so the button tones wouldn't disturb others, tactile or rumble feedback when the touch buttons are pressed, and several microwave safety features such as metal detection. And I will now be demonstrating you a digital interface that I had built using Adobe Flex 3. As you can see, it's virtually the same thing as we had in our original paper design. You can open and close the door. To set the cook time, you can say you want it to cook for 7 seconds or 70 seconds, and you can start the timer. And you can add 15 seconds to the timer if you wish, or even a minute. And you can, of course, click cancel. Timer provides a very similar function. Say 23 seconds if you're cooking something in the oven. And you click start, and then you can click cancel. And then through our simplification, you would simply click the menu button, and then set clock. And then say the actual time was, say, 2:30, you hit 2:30. And then you can hit start. And then go back to the main screen, and as you can see, the clock is now 2:30. If we were to continue our work on the microwave interface, we would like to perform additional usability testing that would include user satisfaction surveys as well as randomization of the task, so expectancy could be avoided. It would be also nice to have a more actual tactile interface to use as opposed to the fully digital interface that we currently have implemented. Thank you for letting us present our design.